Hello everyone. Today's reading part from Fundamental of Physical Geography textbook for class 11 is about unit 2, and from this unit 2 this topic will be covered the origin and evolution of the earth. This is chapter 2. So let's start. We can remember the nursery rhyme Twinkle Twinkle Little Star. Study nights have always attracted us since the childhood. We may also have thought of these stars and had numerous questions in our mind. Questions such as how many stars are there in the sky? How did they come into existence? Can one reach the end of the sky? Maybe many more such questions are still there in our mind. In this chapter, we will learn how these twinkle little stars were formed. With that, we will eventually also read the story of origin and the evolution of the earth. So, from early theories about the origin of the earth, a large number of hypotheses were put forth by different philosophers and scientists regarding the origin of the earth. One of the earlier and popular arguments was by German philosopher Immanuel Kant. Mathematician Laplace revised it in 1796. It is also known as nebular hypothesis. The hypothesis considered that the planets were formed out of the cloud of material associated with the youthful sun, which was slowly rotating. In 1950, Otto Schmidt in Russia and Carl Weizsäcker in Germany somewhat revised the nebular hypothesis. They considered that the Sun was surrounded by solar nebula containing mostly the hydrogen and helium along with what may be termed as dust. The friction and collision of particles led to formation of a disk-shaped cloud, and the planets were formed through the process of accretion. However, the scientists in later period took up the problems and of origin of universe rather than just the Earth or the planets. About modern theories, origin of the universe. The most popular argument regarding the origin of the universe is the Big Bang theory. It is also called expanding universe hypothesis. Edwin Hubble in 1920 provided evidence that the universe is expanding. As time passes, galaxies move further and further apart. You can experiment and find what does the expanding universe mean. Take a balloon and mark some points on it to represent the galaxies. Now, if you start inflating the balloons, the points marked on the balloons will appear to be moving away from each other as the balloon expands. Similarly, the distance between the galaxies is also found to be increasing, and thereby the universe is considered to be expanding. However, you will find that besides the increase in the distance between the points on the balloons, the points themselves are expanding. This is not in accordance with the fact. Scientists believe that though the space between the galaxies is increasing, observations do not support the expansion of galaxies. So the balloons example is only the partially correct. The Big Bang theory considered the following stages in the development of the universe. One is in the beginning, all matters forming the universe existed in one place in the form of teeny ball, that is singular atom, with an unimaginably small volume, infinite temperature, and infinite density. In two, at the Big Bang, the teeny ball exploded violently. This led to a huge expansion. It is now generally accepted that the event of Big Bang took place 13.7 billion years before the present. The expansion continues even to the present day. As it grew, some energy was converted into the matter. There was particularly rapid expansions within fractions of a second after the bang. Therefore, the expansions has slowed down. Within first 3 minutes from the Big Bang event, the first atom began to form. Within 3 lakh years from the Big Bang, the temperature dropped to 4500 Kelvin and gave rise to atomic matter. The universe became transparent. The expansions of universe means increase in space between the galaxies. An alternative to this was Wells's concept of steady state. It considered the universe to be roughly the same at any point of time. However, with greater evidence becoming available about the expanding universe, scientific community at present favors argument of expanding universe, the star formation. The distribution of matter and energy was not even in the early universe. These initial density differences gave rise to difference in gravitational forces and it caused the matter to get drawn together. This formed the basis for development of galaxies. A galaxy contains a large number of stars. Galaxies spread over vast distances that are measured in thousands of light years. A diameter of individual galaxies ranges from 80,000 to 150,000 light years. A galaxy starts to form by accumulation of hydrogen gas in the form of very large cloud called nebula. Eventually, growing nebula develops localized clumps of gas. These clumps contains to grow into even denser gaseous bodies, giving rise to formation of stars. The formation of stars is believed to have taken place some 5 to 6 billion years ago. What is light year? A light year is a measure of distance and not of time. Light travels at the speed of 3 lakhs kilometer per second. Considering this, the distance the light will travel in 1 year is taken to be 1 light year. This equals to 9.461 10 to the power 12 kilometer. The mean distance between the sun and the earth is 14 crore 95 lakh 98,000 kilometer. In terms of light years, it is 8.311 minutes. Formation of planets. The following are considered to be the stages in the developing of planets. 1. The stars are localized lumps of gas within a nebula. The gravitational force within the lumps lead to the formation of core to the gas cloud and a huge rotating disk of gas and dust develops around the gas core. 2. The next stage, the gas cloud starts getting considered and the matter around the core develops into small rounded objects. These small rounded objects, by the process of cohesion, developed into what is called planetesimals. Larger bodies start forming by collision, and gravitational attraction causes the material to stick together. Planetesimals are a large number of smaller bodies. 3. In the final stage, this large number of small planetesimals accrete to form a fewer large bodies in the form of planets. Evaluation of the Earth. Do you know that the planet Earth initially was a barren, rocky and hot object with a thin atmosphere of hydrogen and helium? This is far from the present-day picture of the Earth, hence there must have been some event processes which may have caused these changes from rocky, barren and hot Earth to a beautiful planet with ample amount of water and conductive atmosphere favoring the existence of life. In the following sections, you will find out how the period between the 4,600 million years and the present led to the evolution of life and the surface of the planet. The Earth has layered structure from the outermost end of the atmosphere to the center of the Earth. The material that exists is not uniform. The atmospheric matter has the least density. From the surface to deeper depth, the Earth's interior has different zones, and each of these contains materials with different characteristics. Evolution of lithosphere. The Earth was mostly in a volatile state during its primordial stage. Due to the gradual increase in density, the temperature inside has increased. As a result, the material inside started getting separated depending on them densities. This allowed heavier material like iron to sink towards the center of the Earth, and the lighter ones to move towards the surface. With passage of time, it cooled further and solidified and condensed into smaller size. This layer led to development of the outer surface in the form of a crust. During the formation of the moon, due to the grand impact, the earth was further heated up. It is though it is through the process of differentiations that the earth-forming materials got separated into different layers. Starting from the surface of the central parts, we have layers like a crust, mantle, outer core, and inner core. From the crust to the core, the density of the material increases. We shall discuss in detail the properties of each of these layers in the next chapter. Evolution of atmosphere and hydrosphere. The present composition of Earth's atmosphere is chiefly contributed by nitrogen and oxygen. You will be dealing with the composition and structure of the Earth's atmosphere in chapter 8. There are three stages in the evolution of the present atmosphere. The first stage is marked by the loss of primordial atmosphere. In the second stage, the hot interior of the Earth contributed to the evolution of the atmosphere. Finally, the composition of the atmosphere was modified by the living world through the process of photosynthesis. The early atmosphere within hydrogen and helium is supposed to have been stripped off as a result of the solar winds. This happens not only in case of Earth but also in all the terrestrial planets, which were supposed to have lost their primordial atmosphere through the impact of solar winds. During the cooling of Earth, gases and water vapors were released from the interior solid Earth. This started the evolution of the present atmosphere. The early atmosphere largely contained water vapor, nitrogen, carbon dioxide, methane, ammonia, and very little of free oxygen. The process through which the gases were outpoured from the interior is called degassing. Continuous volcanic eruptions contributed water vapor and gases to the atmosphere. As the earth cooled, the water vapor released starting getting condensed. The carbon dioxide in the atmosphere got dissolved in rainwater, and the temperature further decreased, causing more condensation and more rains. The rainwater falling onto the surface got collected in the depressions to give rise to oceans. The Earth's oceans were formed within 500 million years from the formation of the Earth. This tells us that the oceans are as old as 4,000 million years. Sometimes around 3,800 million years ago, life began to evolve. However, around 2,500 to 3,000 million years before the present, the process of photosynthesis got evolved. Life was confined to the oceans for a long time. Oceans begins to have the contribution of oxygen through the process of photosynthesis. Eventually, oceans were started with oxygen, and 2,000 million years ago, oxygen began to flood the atmosphere. Origin of the life. Origin of life. The last phase in the evolution of the Earth relate to the origin and evolution of life. It is undoubtedly clear that initially the Earth or even the atmosphere of the Earth was not conducive for the conducive for the development of life. Modern scientists refer to the origin of the life as a kind of chemical reaction which first generated complex organic molecules and assembled them. This assemblage was such that they could duplicate themselves, converting inanimate matter into living substances. The record of life that existed on this planet in different periods is found in rocks in the form of fossils. The microscopic structures closely related to the present form of blue algae have been found in geological formation much older than some 3,000 million years. It can be assumed that life began to evolve sometimes 3,800 million years ago. The summary of evolution of life from molecular bacteria to the modern man is given in the geological time scale.